Software engineers are now translating ideas into functional applications in hours. AI coding tools generate logic at a volume outpacing traditional oversight. This chart tracks production volume at a major financial firm. In a single month, output grew from 25,000 lines to 250,000. That surge created a million-line backlog. Demand for human review exceeded capacity, stalling the validation pipeline. Historically, the primary obstacle in software development was the time required to write code. Today, the challenge has transitioned to the validation and governance of those outputs. Organizations now deploy software before they can complete a manual verification of the underlying code or the vulnerabilities it might contain. High production volumes lead directly to an increase in security flaws. AI models often generate code that appears functional but contains subtle vulnerabilities that bypass traditional automated filters. Because many AI coding tools require significant local processing power, engineers are downloading proprietary code bases directly to their laptops. A single lost device now exposes a company's entire software library. At the same time, employees are feeding sensitive organizational data into unapproved public AI tools, creating a layer of hidden risk known as shadow AI. Despite widespread hiring freezes in the tech sector, companies face a global shortage of security engineers qualified to audit this influx of machine-generated code. When a business cannot govern what it builds, development speed is no longer an asset. It becomes a source of systemic exposure. Operational success in this environment depends on a dedicated control plane. Building a system to manage the AI tool lifecycle allows a company to maintain oversight as their software library expands. The Prem Cloud portal serves as this control plane, functioning like a breaker panel. In Phase 1, it mandates registration, scanning network traffic to identify shadow AI. An intake process evaluates data sensitivity and vendor security to assign a specific risk level. Identifying and categorizing these tools at the point of entry is the only way to prevent unmanaged data exposure. Once categorized, the application enters Phase 2, where it is integrated into a zero-trust architecture. The system enforces the use of pre-authorized APIs and granular access management. This ensures that the application only connects through compliant, fully encrypted channels based strictly on a need-to-know basis. A dedicated internal security layer filters all outgoing data. It masks sensitive information before it can reach a third-party AI model, keeping proprietary data within the corporate boundary. Within this framework, an AI application is treated as an untrusted entity until it successfully clears every structured interaction point. Phase 3 is the formal gatekeeping step. The portal generates a security assessment report, issuing an authority to operate only when risks are addressed. In Phase 4, authorization begins an active audit, initiating real-time monitoring of all data flows. Automated compliance checks and scheduled tests verify the application against its original controls, preventing the security posture from degrading over time. Major enterprise breaches frequently occur after deployment, when unmonitored security controls fail to adapt to changes in the environment. Routing the production of machine-generated software through the Prem Cloud portal brings order to the current surge in code output. This four-phase process transitions unmanaged AI tools into a state where they are vetted, authorized, and integrated with corporate standards. Organizations no longer face a binary choice between rapid software delivery and the demands of enterprise security. By implementing a central gateway, organizations can utilize high-volume code generation while ensuring their proprietary data remains under corporate control.